Okay, so this conversation is just a natural consequence of our previous conversation, introduction to atomic mass, atomic number, and mass number. Now we're going to talk about atomic mass and isotopes. Now, I've got here a picture of a sort of a periodic table like entry for magnesium. Magnesium, and I want to point something out here that when you see symbols like this is going to be the atomic number, which I'm going to use for Z, okay? And this is the mass number, which I'm going to use for M, right? I'm going to call that M and that Z, all right? The mass number is 24, the atomic number is 12, and that you can tell what's going on here, right? So that means that magnesium's got 12 protons, and if it has 12 protons, protons plus neutrons is equal to mass number. If it's got 12 protons, and it's got a mass number of 24, that means it has 12 neutrons also, right? So, all right, so our learning goal for this section is to determine the number of protons, neutrons, and electrons of an isotope, okay? And we're not going to calculate the mass of an element. I'm going to tell you about it, but we're not going to do it. Okay, so again, isotopes, as I said in the previous slide, the mass number is going to go here, and the atomic number is going to go here, if we want to say something about the isotopes. So the core chemistry skill is writing atomic symbols for isotopes, right? Now remember, isotopes are atoms of the same element, but they don't always have the same number of neutrons, right? They always have the same number of protons if it's the same element, but they might not have the same number of neutrons, and so that's why we write what isotopes are, okay? Now isotopes have different mass numbers from each other, and they have the same number of protons but different neutrons, which is what I said. And they can be distinguished by their atomic symbols, okay? So now that you know that, this is the mass number, this is the mass number, and this is the atomic number, and this is the symbol. Let's do a learning check, give you a chance to practice. Okay, so please pause the video and write out some notes for this. Give the atomic structures, the atomic symbols, determine the number of protons, neutrons, and electrons. Okay, so I'm going to suppose that you paused the video and that you did what I told you to do because you're a cooperator, all right? So oxygen, the number of we know this. The number of protons plus the number of neutrons is equal to the mass number. And we know that the number of protons is here, right? So 8 plus the number of neutrons is equal to the mass number, which is here, 16. Okay? And so we can see that the number of neutrons is equal to 8, okay? So protons is 8, and electrons, because there's no charge, right? There would be, if there were charge, we'd put something there. So the number of electrons is equal to 8, okay? So what about phosphorus? Phosphorus, we know that the protons plus neutrons is equal to the mass number, right? And the number of protons in phosphorus is 15 because it's given to us there, right? 15 plus the number of neutrons is equal to the mass number, which is 31. Okay, so it looks like the number of neutrons is equal to 16, number of protons is equal to 15, and the number of electrons is equal to 15 because there's no charge, right? All right, so let's do the last one here. Zinc. Protons plus neutrons is equal to the mass number, right? And the number of protons is 30. 30 plus the number of neutrons is equal to 65. Okay? And so it looks like the number of neutrons is equal to 35. Number of protons is equal to 30. And number of electrons is equal to 30, right? Because it's neutral. All right. So now let's talk about this a little more. Magnesium, as an example, has 3 naturally occurring isotopes. That is, if you go into nature and you pull out an atom of magnesium, it might have 12, right? It might have a mass number of 24. It might have a mass number, let me highlight this instead. It might have a mass number of 24. It might have a mass number of 25. And it might have a mass number of 26. Well, how do you know? Well, we don't know until we measure it. That's really what it comes down to, okay? But we do know this, that about 79% of magnesium is magnesium-24, okay? About 10% is magnesium-25, and about 11% is magnesium-26. All right, so if you take those and you average them all out, 78%, which is, I'm going to write as 0.7870 times magnesium 24. This is how you do a weighted average, right? That's 10.13% times 25, and 0.1117 times magnesium 26 will give you the average, right? This is the mass of magnesium 24. This is the mass of magnesium 25. My handwriting is terrible. And this is the mass of magnesium 26, and that would be your average mass, okay? That's just a weighted average. That's not chemistry or physics. It's something that you may have learned in another class sometime. Or you probably did. You probably did learn it in another class sometime, but it's a good thing to see. All right, so the isotopes of magnesium, as you would know, the number of protons are 12 for all of them, right? Because they're all magnesium, right? Now, if they're atoms, then the number of electrons is also 12. But the mass number for magnesium 24 is 24, and so it has 12 neutrons. The mass number for magnesium 25 is 25, and so it has 13 neutrons, right? And the mass number for, let's go back to pink, magnesium 26 is 26, and so it has 14 neutrons. All right, and here are the masses of each one, okay? And here are the percentages, and with that, we could calculate the average, which we're not going to do. All right, so naturally occurring carbon consists of 3 isotopes, carbon 12, carbon 13, and carbon 14. So let's fill this out. You pause the video and fill this out and then come back. Okay, let me suppose you paused it, and let me fill it out with you. Okay, the number of protons is 6 because carbon is carbon 6. That's the atomic number, 6, right? All right, and so the number of protons for all of them is going to be 6. Okay, number of electrons is going to be 6 for all carbon atoms, right? And the number of neutrons, that's going to be different now. This is 12, and so this must be 6. This is 13, so that must be 7. And this is 14, so this must be 8 neutrons in carbon 14. All right, I think I got the... Okay, another one, yep. Pause the video and write the atomic symbols for atoms with the following subatomic particles. Write the symbols for atoms with those particles. Okay, let me suppose you did that. And so I know 8 protons is going to be, just a minute here. 8 protons, there's my atomic number 8, so that must be oxygen. Right? So it's going to be oxygen. And it's going to be an 8 down here, right? Because it's oxygen. And if it has 8 neutrons, it must be, the mass number must be 16, because this plus this, right, is the mass number, okay? And if it has 8 electrons, then we're going to leave that blank because it's neutral. All right, so let's do the atom with 17 protons. It's going to be 17. Let's come over here. That's chlorine. Can you see it right there? Chlorine, okay? And if it's got 20 neutrons, it means the mass number is 37, right? Now, this is redundant, by the way. Sometimes people just write it like this. These two, chlorine and 17, are redundant. So you could just write it like this, right? It's the same thing. Okay, so let's do another one. Let's do 47 protons. We got to find 47. Where's 47? Aha, there it is, right there. Silver, 47. Okay, so silver, and I'm going to put the 47 there. Don't have to, but I'm going to put it there. And if it's got 60 neutrons, well, this plus this looks like 107, right? So this symbol, and it's got 47 electrons, so it's neutral. So the symbol for this is silver 107. Okay, and one final learning check is here. pause the video and come back and say which pairs are isotopes of the same element, and in which of the pairs below do both atoms have 8 neutrons. Okay? Okay. So, let's do this element here. I'm going to hopefully paused it. P plus N is equal to M, right? And P is 8 plus N must be 7, right? Is equal to 15. So these two are not the same element, right? Because that's got an atomic number of 7, that's got an atomic number of 8, right? So this is not 1, and it's not 2, right? Because if this has 7 protons, it must have 8 neutrons. And this one has 7 neutrons, right? So what about this one? These are both the same element, so yes, they're both the same element. But they do not have the same number of neutrons, right? Because this one's going to have 6 plus blank is 12. It must be 6. This must have 8. So this is not 2, right? And these are not the same element, okay? I'm going to guess that they have the same number of, 8. They both atoms have 8 neutrons, okay? So 7 plus blank is equal to 15, right? And 8 plus blank is equal to 16, right? You see what I did there? That's that one, and that's that one. And I can see they're both 8. So yes, these both have 8 neutrons. Okay? And so I think the last thing I'm going to do here is I'm going to skip calculating atomic mass. We're not going to do it. All right, so that'll be it for this. All we did was we went through and really teased apart isotopes and atomic mass.